Thanks, everybody. So again, my name is Justin Wolf, and we're going to talk about Opus Suite, which is a tool for calculating and optimizing cost. Cost as a function of weapon system performance, and then also understanding the readiness associated with your various platforms. The tool suite that we'll go through in just a few PowerPoint slides to kind of kick things off before we actually show some of the models. But the key thing to remember here, the demo case that I have is very aircraft centric, but if it flies, floats, or rolls, there's a place for Opus Suite in understanding cost and performance. And we'll talk about some various examples of this as we go through the PowerPoint. So, let me just catch up here. So Systecon, has been around in one form or another for quite a long time. We'll give a little bit of a company overview. We'll talk a little bit about Opus Suite, and then we'll actually go through the software itself and show how this all actually comes together. But just as a key sort of understanding, we're going to understand that relationship here between performance and cost. So, a lot of the parametric cost tools that are out there don't really take into account your probability of mission success or your availability at various cost points and things like that. But that's really where Opus as that performance and cost model is really focused. Systecon's been around in one form or another since 1970. In 2011, we reincorporated here in the United States as a Florida corporation. We also have offices in Virginia, Texas, and Georgia. And around that 2011 timeframe is probably where some of the folks that have been involved with ICEA since then have started seeing us at some of the trade shows. We've also have international offices and maintain the presence in Sweden, the United Kingdom, Australia, Germany, and South Korea. And our tools and services are used by 24 other countries' defense departments besides the US DoD, and are used by more than 150 commercial or pseudo-commercial in the case of the Lockheeds and Northrops and Raytheons globally. So just to highlight some of our key customers, the entire US DoD and CAPE actually use our software today to do cost and performance analysis. In addition to the US DoD, we also actually have the software mandated for use inside of the UK and Australia, and a number of other NATO and aligned countries in Asia also use the software as well. Of course, that drives industry behavior, so a lot of folks inside of the OEMs utilize the software as well. I was actually exposed to the software while I was working at Lockheed Martin before I joined Systecon in 2011 when we reincorporated here. So it's been around for a long time. This isn't something that was created yesterday. And I think one of the key things there to take away, the software has been through a full validation and verification. It's fully accredited, and it's available for installation on all of the DoD networks, to include JSP on the OSD side, the Air Force network, the Army network, and the Navy NMCI network as well. So, available and able to be used on the networks, which is a key capability there as well. So when we think about what the software does, right, there's kind of three major sort of macro areas for study or analysis that makes up Opus Suite. The first is optimizing our logistics support organization. So that's more of your budgeting, but also some forecasting capabilities there. When we think about, if I'm going to invest $1 in weapon system, where should I put it? Should I buy more spare parts? Should we invest in additional people? And what's the trade-off across each one of those things? Which parts, which people, what skill categories are going to maximize my overall operational effectiveness? We can then run an entire array of simulations and SimLogs that allows us to understand how a particular solution, whether it's optimal or not, will perform in some very discrete mission scenarios. So we load in our mission profile for our deployment and understand how that afloat spares package is going to perform, and then what costs are going to be generated through that operational profile as well. And then all that gets wrapped up to generate cost work breakdown structure that fits, the current CAPE structure or IEC or NATO standards or whatever different cost work breakdown structure you need to fit all of those results into. So as we go through the demo, we'll show how each one of these tools is used to generate cost and performance analyses and generate good reporting that can be used to inform senior decision makers about the best course of action. Not only do we have the graphical user interface that you'll see as I go through the model, we also have a well-defined API that allows you to populate really any external dashboard that you might want. So if you currently have a Tableau visualization that shows current availability or current costs or historical costs on your program, you can also use Opus's API to populate that same Tableau dashboard. And it can perform an array of different studies. We can model and simulate the impacts of different decisions on as far as the design of our systems, the performance of those systems, cost and risk. We can identify those cost drivers. And again, this is forward-looking, not just looking at that historical data. We can set and evaluate requirements on our PBL support contracts, so set those incentive and penalty functions appropriately. We can understand at a fleet level the cost and performance. So if we were to take money from one PEO and give it to another, what's the impact on readiness? And a whole host of other different trade studies. And a key factor here is you can imagine some of these studies, like doing a location of repair analysis, for example, may be very data intensive. So you need to be able to import a lot of data, and you may not have everything at the beginning of a program's life. In that case, we do have a full integration with SEER. So if you have some of those parametric models that were built during a proposal phase or pre-milestone C, you can import those models and have a good starting place to then populate more detailed information as it comes available. So that's something that is pretty useful as we transition maybe from early onset program into later in operations and support phase. These types of analyses have now, in the Navy anyway, been mandated. So the use of Opus on future frigate and unmanned systems and across the larger Navy Common Readiness model, Opus is mandated for use. So if you're joining us from inside of the Navy, you're going to start to see Opus more and more in the coming months and years as it rolls out across more and more program offices. Some of the performance aspects of this, as we think about optimizing performance and cost, or understanding the level of cost that will allow us to achieve certain levels of performance. Within AMDR, we helped them understand what was necessary and optimal to achieve their key performance parameter of a 98% operational availability. That allowed them to understand the package that Raytheon was proposing for spares and manpower levels and contractor logistics support, and trim that by a little over 200 million. Then there's some long-term cost avoidance there as well on top of that. The program was actually awarded the 2017 Stan Arthur Award, and Captain O'Connor in 2018 was awarded the NAVSEA Program Manager of the Year. Directly in the write-up was tied to this work done with Opus Suite. On JSF, in the last couple of years, as the program works to turn the corner from decisions that were made in the past, their independent cost assessments through CAPE and the program annual cost estimate are actually built using inputs from Opus. We do all the spares optimization and performance analyses to understand how various levels of cost are going to result in various levels of mission capability rates. And the software is also used to define those risk measures and performance measures associated with the 2020 and beyond contract performance metrics. We have some references here for folks that are interested in learning more. Depending on which organization you're in, we've got quite a lot of work going on with the Air Force, the Navy, and then directly with the sustainment office inside the Pentagon. Okay, so enough PowerPoint. I could bore everyone to death with PowerPoint slides, but hopefully you all are interested in seeing more about how the software actually works. A couple of different demo scenarios that we can use to go through here with 40 or so minutes before we get into Q&A. But one of the cases that I really like to show is a situation where we may have an existing program. You know, we need to understand how much is it going to cost to support our program for the next year of operations, and what level of readiness can we expect to achieve. And so very quickly, I'll just pull this open and we'll sort some of the tables here to understand, and I'll explain what we're looking at. Over here on the left-hand side under the tab labeled item structure, I have my system. In this case, my program is supporting this helicopter, and we're going to have 44 of these helicopters deployed over the course of the next year. The helicopter is made up of various assemblies and parts, and some of those are repairable. They'll be the color green there, and some are consumable. Those will be that color blue. We have these systems deployed in various locations around the world. Now, this is kind of a simple structure where we have a central repair depot that's supporting our land-based systems and our ship-based systems in this case. But this could be infinitely complex, right? As you think about DoD operations or F-18 or F-35 or, you know, battle group scenarios, you know, there's a lot of different nuances and things there. Transport times and things, and transport costs and everything else that might go into that. And then we have the location of where we currently have parts and people and everything else that's going to allow us to be mission capable. And from this, we can calculate what the next year of operations is going to cost and what level of readiness, if we do nothing today, what level of readiness will we achieve? And what we can see is that the next year of operations is going to cost $7 million as a small fleet, and will achieve an operational availability of 49%. Now, you know, I can't tell you if just based on this single data point, if this is good or not, right? And so what we might want to do is compare this baseline, right? Understanding where we are today and what level of performance we can expect in the next year to some optimal solution. So if we were to be able to go back in time and buy all the right things and make all the right decisions, we would achieve something potentially different. And so we can run that analysis and say, well, how bad is it? And what we can see here is that for that budget, right, when we think about the spares that we have deployed and the people and where they're located, you know, we're really not doing so great. We could potentially, for about the same budget, I'll box this info so that way we can see about the same budget, a savings of maybe $50,000, so nothing super significant. I could potentially achieve a 21% higher system availability. Now, that means, though, that I would need a different mix of spares, maybe a different mix of people. We're spending the budget, right? So our program costs the same, but has a very different outcome from an effectiveness perspective, right? And so we might want to understand what that is. And so we can see, if I look at the tabular view of this, which looks a lot like, you know, a pivot table, what I can see is that from a spare parts perspective, in our baseline in column A, I have way too many of some parts and not nearly enough of some others. And we're able to quantify exactly what those deltas are. That is going to allow us to achieve this much higher A sub O, even though we're, from a cost perspective, achieving the same cost. Now, if we have this system fielded already, right, all we can do is buy our way out of this hole, right? And that's what's happening today on the F-18 program, where we're helping the program understand what the best course of action is to maintain their fleet readiness. And so that's what we call a reallocation and replenishment. Let's see if we can put those people and those spare parts somewhere better, and then give us some options to buy additional spare parts, maybe deploy some additional people, and increase our availability even more. And so this is the situation that we can see here, where if we want to get to that 75% A sub O target, we're going to have to make some strategic investments of about 1.7, almost $1.8 million in order to get there. Not only that, but we're going to have to take a small hit to be able to make those investments, because we're going to have to push some spare parts around, and in the process of doing that, the material movement and things like that is going to actually introduce cost to the program and a momentary drop in our A sub O as we have sort of material not available at any given point in time. It's sort of in transit or something like that, moving around between sites. So here we can see the penalty for not doing analysis early, is what we can see here, where we're able to achieve maybe 70% A sub O for about the same budget as we had in our baseline. And if we wanted to buy our way out of that hole, we've now got this $1.3 million gap. And this is just a year of operations, right? So you can carry that forward across the life cycle for any amount of time. We could look at, and we will actually look at a 10-year horizon later as we generate something closer to a life cycle cost estimate. But again, this is why it's important to do this type of analysis as early as possible, and what really drove us to integrate with SEER to make sure that we can support early cost estimating activities as they transition from purely cost estimating to cost and performance analysis later on in the program's life. Now, one of the interesting things, in the tactical fighter realm that we've seen in the last year is this drive through Secretary Mattis's memo to achieve an 80% mission capability rate across the fleet. And that's a great goal for sure, right? I mean, the higher the MC rate in theory, the more likely we are to be able to accomplish mission hours. But that's not always a fully accurate statement, right? Mission capability doesn't necessarily mean full mission capability, and there's some subtle nuances there. And we're able to actually simulate all those differences. And additionally, with maybe a 49% aircraft availability in this case, allows us to accomplish all of our requested flying hours. And so we might want to understand that as well. If we have a flying hour program that we want to go fly, do we really want to pay to have an 80% mission capable rate if 49% allows us to fly all of those projected hours? And that's just decision support for a program to understand their options. And maybe 49% is completely inadequate. And so what we can do is we can take these same models and actually start to simulate what this looks like. So we'll run a quick simulation of that same 49% A sub O that we were just looking at there. And again, in real time using multi-core processors, I'm able to show, what are the mission results associated with that 49% A sub O. So here, we're going to accomplish 70% of the requested flying hours. We can look at this not only in percentages, but in raw numbers. And over the course of the next quarter or whatever the time period is that we're looking at, we're going to miss 1,300 mission hours. So in my mind, I would say that probably that 49% A sub O is insufficient. Now remember, Opus is going to optimize our spares and our manpower and the amount of support and test equipment, really any resource that we might need. But a program may be budget limited. They may only have certain colors of money available to buy spares. They may have fixed manpower limits. And so we may want to be able to show a program, okay, what are the causes of downtime associated with that particular support solution that we propose to field? And we can see here we have some different colors that I'll explain very quickly. Starting at the top, we have dark blue. That's our unscheduled maintenance or active repair. So we have the part, we have the people available, we have the tech documentation and everything else that's required, but it just takes time to actually fix the part when it breaks. That's basically the wrench time associated with fixing our system. Then we have the light blue. That's our active preventive maintenance. So again, these are scheduled maintenance events. Maybe every 300 flying hours we have to do some kind of check. Or maybe we have to pull an engine every 1,000 hours and do some sort of overhaul. And the time it takes to perform the scheduled maintenance event, given that we have the parts and people available, is that light blue. And then we have this orange, which is awaiting resources. So something has happened, whether it be scheduled or unscheduled, but we don't have the resource available to do the work. And resources in this case is a broad bucket that we can drill down into, but it'll include our people and our support and test equipment and technical documentation and things like that that just may not be available. And then red is awaiting items, and that's pretty self-explanatory. That's a system is down and for some reason, scheduled and unscheduled maintenance, and it needs a part that is not available. So over the course of this simulation, what we're able to see is we have various causes of downtime. Now remember, we're looking at mission capability here. So we may have a system that's available, but it doesn't have enough systems, right? And that may be a situation where you don't have the wingman. So you can get one aircraft off the ground, but you have to get two off the ground to be mission capable. So in this case, we may have some mission assigned aircraft at locations, but because we don't have the correct amount or the correct configuration, we're not able to actually operate and go out on mission, which is again this last area here in yellow. And you can see that we have a non-constant utilization where we have a spike or a surge in our desired operating profile over the course of this period of time. And so if we're going to make some improvement, you know, everyone always likes to beat on the supply guys, right? They always want to, well, if we could just have our spare parts, we would be operational. Our squadron knows what they're doing, and we're able to get our fleet of 44 systems up and off the ground, but the supply guys can't get us our spares. And that may or may not really be the case, and we can show that, well, if we were to take a suboptimal solution and instead of doing what Opus has recommended, we only invest in spare parts, well, we can show somebody exactly what that looks like. And so we can run this simulation and very quickly understand, well, if we were to take just the spare solution, we're going to do a really good job of cutting down our non-mission capable supply, but we're going to see a resulting almost a one-for-one increase in our non-mission capable maintenance. And so as we look at that, what we can see here is this situation where you've replaced one form of downtime with another. Because the bottleneck wasn't spare parts, it was in this case people, you never had the people to do the work to begin with. So simply adding more spare parts doesn't allow you to increase your overall mission effectiveness. And we can see that as we look in our mission results and see that we don't see a very large increase in our number of mission hours accomplished. If we look at this in percent, it's a little bit over a 1% increase or 2% increase in our overall mission effectiveness rates, which isn't really moving the needle, right? I wouldn't call this a win, right? What we really need to do is show somebody, well, what happens if we implement that solution from Opus? And we can do that here and show that we can get our system's operational effectiveness or mission completion rate up quite a bit. And as we run these simulations, just takes a few seconds, we can now get pretty close to a 90% mission success rate by implementing that optimal solution. And we can see now the causes of downtime are really limitations in our system itself, right? We have a lot of maintenance going on. We have the parts, we have the people, the systems just break a lot and require a lot of maintenance. And so we need to make sure that we have the right things available. There's not much we can do from a logistics optimization standpoint here. So now it's time to think about something else, right? We could add some more people, but it's not going to help a lot and probably be really expensive. We're way up the curve already from a spare parts perspective, kind of well past the knee in the curve, so to speak. And so we have almost 35% of our systems down for scheduled and unscheduled maintenance. So this is where we might start informing the program and doing some cost-benefit analysis associated with, you know, maybe reliability and maintainability improvement programs. And we can help a program quantify, you know, what are the things that we should explore from a reliability and maintainability improvement by focusing on, well, what are the parts that are driving our downtime, right? We have a significant number of maintenance events occurring here. If somebody has a reliability or maintainability improvement program, I'll pull the top 20 parts off this list here and be able to show, okay, well, what are those top 20 components? If somebody has some idea to improve the maintainability or reliability of parts out here on the tail, we might not really be excited about that. The ones that are driving our downtime are these, you know, maybe top 5, really top 2, but we could expand that to be maybe the top 5 there. And we can see, well, you know, what is the cost and what is the performance impact of any improvement to those top 5. And so what I can do is I can pull up a bit more long-term, like over the remaining life of our system, what's the baseline, and what level of cost will we expect to achieve if I were to improve the reliability of those top 5 components. Right? A 25% improvement in those 5 components doesn't necessarily mean my life cycle cost is going to go down by a significant amount. And so what we might, because there could be some significant non-recurring engineering charges, there could be many parts, and so those don't have an impact on the whole. But what we're able to see here is that over the next decade or so of operations, the remaining useful life of our system perhaps, if we were to try to target a certain level of availability, we can see that there's some $15 million savings that's possible, and we can look at this on a year-by-year basis as well. But just over the remaining decade of our systems operations, we can expect if we're able to achieve this reliability improvement, we could see some fairly significant improvements in cost. And that includes, by the way, a $10 million non-recurring engineering charge to implement these reliability improvements. If that NRE exceeds, let's say, $25 million, then you might not see the payback, right? We have a baseline here and a proposed improvement that's going to save us $15 million with a $10 million investment. So $25 million in support cost savings, $10 million investment gets us to this net support cost of $15 million savings. So, we have $25 million to play with here. If the engineering team comes back and says, hey, it's going to cost $100 million to save 25, maybe that doesn't make a lot of sense, right? So we have that now decision support to be able to break this down and understand the cost implications and readiness implications of decisions that are made on our program. So to transition that, we can then build some really detailed cost estimates that really dig into the various elements of cost and run some real intuitive insights here. I have a cost work breakdown structure that's actually used in Europe, so it'll look a little bit different. In addition to that, we also have cost templates that are built in to include the CAPE ONS cost estimating guide, some other formats and things there as well, including the European standards and things like that. So I can just pull up the template for the CAPE guide, and that'll probably look fairly familiar to some of the folks here on the call. But whatever template or custom cost work breakdown structure you're interested in building, the relative inputs, or in this case parameters as we call them, remain the same, right? You have prices, you have man-hour costs, you have all those different knobs and dials that we can twist as we look to calculate cost versus performance. And from this, we can understand, well, over some period of time, what level of cost will I probably achieve, right? And in this case, we can see the total cost, right, our life cycle cost, but then we can start to break this up across various dimensions, right? So we have some different things down here. We can look at time, which I think is an interesting one, where we can see, well, in what years are we implementing costs? Where will we see costs? And as you would imagine, you have some early costs up front in a program, and then you have some operating costs, and then maybe disposal costs out here on the end. Now we can drill into this and understand, well, what are those cost elements inside of each one of these years here? We can click on the y-axis and we can expand this a little bit, and we can look at maybe the first level, which for this particular cost work breakdown structure consists of acquisition, support, operating, and termination. And we can click that, and we can see here that we have acquisition costs, operating costs, and termination costs of our system. And if we wanted to continue drilling in, we could expand this and expand all and get quite a lot of detail out. And you can see that, as we build up slowly some insights inside of our data. Now, in addition to time, we can also look at those material cost drivers, and we can expand that in or out as necessary. We can also understand the locations in our model that are driving our results, right? So that's also can be an interesting view, and I'll kind of consolidate this for a moment and just look at our LCC. And then another interesting factor is we can compare different solutions. So let's say we're looking at evaluating a proposal, and we want to understand how two different vendors' solutions are going to perform. This is something that the Navy is actually doing today with Future Frigate. Right? They're actually requiring that vendors submit their Opus models, which will allow them to run a comparison of the various vendors that are submitting designs for the ship class. And so here we've got two different vehicles, two different systems, and we can calculate the second one, and just very quickly, side by side, compare the life cycle costs of each one of these systems, and then of course do the various analyses where we might look at these over time and compare the vehicles side by side, see when those costs are being incurred, and then drill into those cost elements as necessary. Again, the same way that we were looking at them before, drilling into that cost to work breakdown structure allows us to view, and this maybe looks a bit like an eye chart, but there's always a pivot table view that we can pull this information out of, copy and paste this in some tool, and do other visualizations that might be necessary. Not only that, but you'll notice we can have the sensitivity button there. We can run a whole host of sensitivity analyses on costs. Again, keeping in mind the performance aspects as well, right? Anytime we change a cost element, there will be some impact on our overall performance. That's really important to keep in mind, right? The cost and capability are very much aligned with one another. We just need to make sure that we do so and invest in the right things. You know, some of the challenges that we've seen that we've helped the F-35 program overcome, you know, are we buying the correct parts? We may spend our billion-dollar budget on spares, but if we don't buy the right components, we're not going to see a resultant level of capability that we would consider to be a capable system or the right level of performance, right? And so understanding that nuance around, well, what are our material cost drivers? What are the things that are driving downtime? What is our life cycle cost associated with the decisions that we might make are really the areas of focus where Opus here really shines. Now there's a ton of, like I said a bit before, there's a ton of customization that you can do. And so as we look to, you know, populate this with other tools and other models, we actually have really well-defined APIs, things like that that allow you to control the models, understand and populate dashboards with these visualizations that we can see here. And then you can always also, you know, just copy the pictures, you know, and paste them in a PowerPoint or something like that. And since they're pasted as vector files, you can edit them and kind of do whatever you want to do to make the data look, you know, per your organization's visualization requirements, you know, different shades of blue or different shades of whatever the right color schema is for your organization. Lastly, you know, as you can imagine, the training required to, you know, to use this model effectively, you know, requires a few weeks, right? We have three-day classes that would make you a proficient analyst. But even then, you may run into some things that you're not familiar with. So you might want to, you know, be building a model and you have some optional columns out here that you may never have used before. Like we have this column here, this batched demands VMR. So we do have clickable context help that allows you to click a field and it will pull up the help file associated with that field and tell you, well, what is a batch demands VMR, right? Well, that's the variance to mean ratio associated with how that component fails. And so we may want to change that from the default value that's here inside of the software. And you can, of course, do that. Maybe you want to do some analysis and populate a dashboard. So you may want to use the external program control feature where you would run it, like let's say through that web dashboard. So we have the API commands and things that are there to be able to run the software and populate those dashboards. So there's a huge amount of information here inside of the help file, in addition to formal training classes that Systecon holds regularly, globally actually, but quite often here in our Arlington office where I am today, to be able to make sure that analysts are able to use the software. And then one last plug, if you happen to be from the Navy actually does have an enterprise-wide license of the software. So if you would like to use the software, you can just put in a help desk ticket with NMCI, and they'll push the software to your machine at no cost. The Navy, through the Navy Common Readiness Modeling Program of Record, has purchased an enterprise license of the software. Other services may incur some costs depending on how many licenses they have allocated and how many are available. And then, of course, on the private industry side, it depends on how many licenses your company has. But we do have existing support agreements with most of the big OEMs, so there are licenses and things available, and folks within your organizations probably that are trained. So if you have any desire to learn more, see how some of the folks are using the model, see some of the results that are out there, we of course support a wide array of user groups and things like that. So we have a pretty close family here at Systecon that we can certainly introduce you to people that may be using the software inside of your organizations or inside of like and similar programs within your various organizations. So went through that pretty quick. I know that was probably a little bit of a fire hose for some folks that maybe haven't seen a lot of this kind of cost and performance analysis and some of the overall mission effectiveness and readiness analysis as a function of cost. But I'll pause there and see, are there any questions from the group? And is there anything that I may be able to dive into in a little bit more detail or provide any additional clarification for?
Well, so far nobody has sent any questions via the question box, but if anybody wants to, you can also raise your hand through your dashboard. If everyone wants to raise their hand, we can open up as well. Oh, they're too shy.
Well, I will say if you do have any follow-up questions sort of after this, feel free to reach out. I think we'll have some contact info distributed after this, so feel free to reach out to Matt, who's sitting here beside me, or me, Justin Wolf, or reach out via LinkedIn or email or whatever method kind of suits you best. And we are recording this, and so we'll have that available. I don't know, maybe we'll throw it up on YouTube or something like that. So if you want to reference this after the fact, that will be available as well.
I sure will. We'll be putting it on our YouTube page as well.
Great.
And also, if anybody missed that contact info, you can always reach out to ICM. We'll be happy to pass you along to Matt and or Justin. Well, I think you wowed them with some knowledge. Unless you want to go into any in-depth on some of the features, do you want to give everybody a little 20 minutes extra on their lunch?
Yeah, I think so. I mean, I hate to just talk for the sake of talking. So, and again, it was a pleasure, Megan. Thanks for putting this together. And thanks everybody for joining. And again, look forward to interacting with some of you after this as we have follow-ups or you guys are interested in learning more.
Thank you, Justin. Thank you, Systecon. And thank you, everybody, for tuning in and listening. We'll be doing some more of these between now and the end of 2019, so you can look forward to that as well. And until then, you guys have a good afternoon.